So as a disclaimer, obviously I am recording the video and I will be recording all the way to the end. If you do have any issues with that, feel free to let me know. Thank you, class. So I'll go ahead and share my screen. And we talked about VPC. Just a rundown real quick, because VPC is a very important concept. So I'll just run down real quick. So VPC, like you see here, is a virtual environment for resources. So if I'm working in the cloud as an engineer, I want to isolate my resources in terms of networking. So how do I create my own data center in the cloud pretty much, right? So let's say I'm just giving an example. You have two companies, right? Or you have two separate products, or you have two products that are not supposed to communicate with each other. How do you isolate that in the cloud, right? That's why you use VPC. VPC creates a separate environment in the cloud, separate cloud environment where everything that runs in that VPC will be able to communicate with each other. But no one outside of that VPC will be able to communicate with your VPC pretty much. So it creates that level of isolation. And then when you go in the VPC itself, now you're going to go to fine-grained, firewalls, rules like security groups. If you watch the video for last class, some of you should be familiar. I'm just doing a rundown of it pretty much. But yeah, all of this will be familiar. Where our subnets, we did create a subnet last class. We did use custom CDR blocks that were provided to us by AWS. We did see some route tables. Route table is basically a table with a bunch of routes, right? One could be going to this subnet, another one could be going to another subnet. And all those subnets could be located in different AWS environments. And then internet gateway, that's exactly what it is. It brings the internet. So if you watch the video for last class, this should be familiar. I'm just doing a review. The internet gateway pretty much brings you internet. That's what it is. If you have, and what happens? This is what happens. You have a route table, and there's a route in your route table. Your route in your route table is going to connect your internet gateway to your subnet. That way, your subnet can have internet pretty much. So that's basically the concept of routing and subnetting. And then the NAT gateway, in your private subnet, you can have a NAT gateway. The NAT gateway points to your internet gateway, and your internet gateway supplies internet to your NAT gateway, and then this NAT gateway supplies internet to your private subnet, pretty much. We did it last class, watch the video, but that's the basic concepts of VPC, and if you can understand those concepts, you'll be good to go. That being said, today we're going to go to the actual DevOps system, if you will. So we're going to start by talking about Amazon ECR. I'm actually excited. I actually did some work today on ECR. So Amazon ECR, before we talk about ECR, we have to first of all understand what the Docker image is. I know there's a separate class for Docker image, for Docker. That one will go more in depth, we'll work mostly with Docker images. But I cannot teach you AWS without teaching you certain things. Like I said, I teach you what I know, I teach you what I use. And if I go through AWS without showing you some of the things that we use, it will be a disservice. So that's why I have to bring up ECR. So Amazon ECR is managed container image registry, right? It's an image registry owned and managed by AWS. Okay, let's take a step back. What is a Docker image? Most people probably know what the Docker image is. Most people don't. But the Docker image is pretty much a lightweight standalone. Like you said, lightweight standalone executable package of an application. And it's not just that application in that package. It also has all the dependencies. Remember, we talked about dependencies. You have applications running, and those applications, they require dependencies. Like today, I was running an application. I was trying to build part of our website, and it was written in Ruby. I kept getting errors. Why? Because the dependency was missing. So when you have a Docker image, you have everything. You have the application, you have all that, and then you have your dependencies in there. So it's all packaged in that image. So that basically that image you have is like a tar ball of an application. So I could take that image, I could send that image to Bazra, I could send that image to Ramen, I could send that image to anybody. And you run that image and you have the exact same thing that I have. So your Docker image solves the problem of weight, because normally an EC2 instance is very heavy in terms of data because it has so many other things that you don't need. So it's lightweight, so it solves the weight problem. It solves the standalone, you can isolate it. So I could send a Docker image to anybody pretty much in this class. Or I could send even a Docker file, and you can build that Docker file and have your own image. And so you have this small application, literally, that has everything you need, and you can run identical applications. So Docker image is such a big thing in DevOps because as a DevOps engineer, you want what we call likeness. So you want your applications to be similar. You want everything to be, very, very similar, if not the same. So Docker image solves that because, the same Docker image, you run the multiple institutions, multiple places, and it's always the same. What is a container registry? Okay, you have your container, right? But you need somewhere to put your container. You can't just leave your container hanging in the air, or just storing it in your machine. You need somewhere we call a registry where you put your images. We're going to talk about this again when we get to our Docker section of the class. But now that we're talking about it, by then you have a better picture. So your registry is a place where you store those images. So when I store my image in a Docker registry, now I can anybody, if it's public, right? That's a keyword. If it's public, if my image is public, anybody can pull it. You can just use Docker pull and you pull an image. If it's private, then you're going to need some kind of authentication. I'll show you exactly what that means in a second. So now we come to what we mean by Amazon ECR. So Amazon ECR, that being said, now Amazon ECR is a registry but now is controlled and managed by AWS. So you need to have an AWS account to have your own registry. There you can push your images. And now you can start to see the possibility. Once you push your image in ECR, now different applications can consume that image pretty much. So and now it kind of ties things together. You have your image, you build your image, you find what do I need a registry? ECR, you put your ECR, and then other applications can consume that image and then deploy it pretty much. And that's the essence of DevOps. That's the mindset of DevOps. So now, ECR versus Docker Hub, right? ECR is a registry. Docker Hub is also a registry. Keep that in mind. But Docker Hub is a public registry. So when you listen to this video, I know a lot of you go watch back this video. When you get to this point that I mentioned right now, what I want you to do is I want you to go to Docker Hub and create an account with Docker Hub. It's free. And then that now you have an account, and now we could build and push images in the future in your Docker Hub account. That will save you time, save you the energy. Just create your Docker Hub account and you get to this spot, and then you can push images. You wouldn't need AWS. The advantage of AWS obviously is because it's managed by AWS. It has automatic scanning, it's safe, it's secure, and then it's highly reliable because it's always going to be up because AWS is managing it pretty much. So that's what it is. That's what Docker Hub is. And then this is a link to more studying if you wanted. So this is just a picture that just depicts what's going on. I create my image through my CI/CD pipeline, whatever you're using. I push that image to ECR. Once I push that image to ECR, now my ECS can consume it. My Kubernetes can consume it. And ECS, we're going to talk about, is just a container orchestration system. And EKS, which is your Kubernetes, can consume that ECR that's in here. You trust me, your ECR or your EKS can also consume images from Docker Hub. Don't get it wrong. But when you have your images in ECR, your images are protected. Your images are safe. When you have it in Docker Hub, then it's a public image. So it becomes a problem when it comes to company software, company information. So just keep that in mind. So anyway, so real quick, so let me open Docker Hub. I'm just going to open Docker. Let me just see. Let me just open the Nginx image so you can see exactly what an image looks. So this is you see, this is hub.docker.com. If you wanted to create an account, this is where you create, sign up. I already have an account. I don't know if it's, I don't want to sign into right now, but I already have an account. But anyways, this image you see right here, this is Nginx. It's a web service. This is managed by the official Nginx. So this is an official image. You can have official images, you can have your own private images, and you can have your own public images. So this is an official image, so which means that you can trust it, you see? And it even tells you that it's been pulled 1 billion times. So when they say pull, this is what they mean, Docker pull. So I'll show you an example. So now if I want to use this image, I'll just pull it. So ECS can consume this image and anybody. So this machine, I just downloaded Docker. Let's see if the Docker demo is going to let me pull. Docker demo. Let me search that Docker demo. Yeah, so normally when you have your Docker installed, normally you run Docker pull, and then you automatically pulls that image. So pulls that image for you. So what I can do, I use Brew to download my Docker a few minutes ago. And if you give me a second, I would authenticate and start Docker. And then I can just do a quick Docker pull. And it's very quick. It can take time. The image is big. It takes a while to pull it. If the image is light, it's going to pull very quickly. And once you pull that image, you have it in your system, you can easily just consume that image anytime you want. So you have an identical service. So any question?
When you say pull, are you referring to downloading it?
Yeah, so when I pull it, I'm pretty much downloading it pretty much. That's what it is. But you know, in the IT and the DevOps field, we call it you're pulling it because you're downloading it, but at the same time you're pulling it from somewhere else. So I don't know why they could have said Docker download.
I understand push and pull. If you're pushing it, you're basically giving output.
Yeah, you're uploading.
You're uploading.
When you're pulling it, you're downloading.
Right.
So that's pretty much what it is. And you know, if you're going to be in the DevOps field.
So am I doing this? Am I doing this on my command line?
Well, the Docker pull, do you have Docker installed in your machine?
No.
Yes, you have to have Docker installed.
I got it.
I can show you. Let me show you real quick. Install Docker. You don't have to follow me, but this machine, and one thing I would like to just bring out is Docker has stopped its support, you know, for like, you know, usually Docker used to be the to-go for everything, but now if you're using Docker in an institutional level, that's just an update, you know, I know you're going to get in the field, but within the last 2 months, Docker stopped its support for enterprise, which means that if you're using Docker for enterprise level, you're going to be restricted. You can't, you know, the license doesn't let you. You have to buy it, you know. But before, Docker used to be free. Docker used to be free. So that's just an update. I know most of us DevOps engineer and some of the nerds, you know, we were very unhappy when we heard that news because we've been using Docker for a long time. So I am downloading Docker. This one is going to give you the Docker desktop. So if you download Docker like this, it's going to give you a Docker, come with a Docker desktop and everything where you can start and stop Docker. You can authenticate your Docker and things like that. So you need, so that's downloading. While that's downloading, we're going to proceed and talk about, you know, ECS. So I know we just talked about ECR, which is a registry of your Docker images. Now, what do you do with those Docker images? I think before even doing that, it might be a disservice. Maybe I should, you know, go in there and show you what an ECR looks like. I know we all have our AWS account, but it's always useful for me to go in there. So your ECR, this is basically what your ECR is. You know, is as plain as this. And when you go to your ECR, you can always create a repository, right? So you have your registry, and your registry has repositories. The reason why you have this repository is so you can separate different images, right? So for example, this is my DevOps image. Let's say I had another service called web server. Then I'll create a separate repo of our web server. And then you don't have to put some of this option and then I'll create. You know, the reason why you're doing all this is because you're never gonna just push one Docker image, right? Each time you want to deploy an application, you have to build that image again and push it. So now when you have your repository, when you keep pushing images, you keep tagging and pushing your images, one is always going to be the latest image, right? But then there's still going to be your old images in there. You can reference to them. You can pull the same old images. So you basically have what we call version in your ECR, where you can see different images. So we're going to go ahead now, but this is how you create a repo. And then when you create a repo, it's so easy. Then everything, once you have Docker installed, if I wanted to build and push this repository, just come here, open this, and then you see everything that you need. So AWS is basically, you know, giving you a handoff. You know, they tell you, you just need to authenticate with this command. So before you run this command, you have to make sure Docker is installed in your machine. Once you authenticate, this you build your image, which I hope I get to do this so you can see. Once you tag your image, and then you push your image, just as easy as it is. So when the Docker finishes installing, I'll update it, and then I could quickly try to authenticate and push real quick. If it doesn't, I'll do it again in a video and I'll post it in the chat. But yeah, that's kind of what it is. So let the Docker install. So that being said, this is an ECR. I'll keep the ECR open because we might have to build and push some images. I'll show you what the Docker file looks like and how you can build and push. That being said, let's talk a little bit about ECS. So ECS is a highly scalable, like ECS, container management system. So what does that mean? You have your Docker image. The reason why I'm focusing on these guys, Docker, today is going to be a lot of Docker, Kubernetes, infrastructure as a code. The reason why I'm focusing on this is because DevOps has changed, right? Now companies are so focused on container orchestration like Docker, Kubernetes, that they won't even hire you sometimes if you don't know what these things are, or these apps are. That's why I thought it would be a die service to go without showing you how AWS. And now with this knowledge that I'm giving to you, it's up to you to go watch the video, do a little bit of practice. But with this knowledge, you're good to go in terms of doing your interview and actually even working on them. You might not be an expert, but you already know what it is, what it does. That's all you need sometimes. If you're going to go to a company that already has code base, has Docker files, has everything. If you're unlucky, you go to a company that needs things to be Dockerized. And then you can also walk through that. And then when you do the Docker course, I'll show you how you can take an entire code base and you can convert it to the Docker image and deploy it pretty much. So what we call Dockerization. So anyways, you guys, anybody, you make sure you make it to the end of this course because I'm teaching everything I know, valuable information. We might not be able to squeeze everything in, but I'll teach you everything I know. Like I said, I posted last time. I see guys, charging for the 500 and they don't even teach half of the stuff I teach, So that's just saying that, I love this stuff. I want to share the knowledge. And there's a lot of knowledge to share. We're not even up to 40% or 30% of what I'm planning to teach. And that's not even, that's just scratching the surface. So that being said, that's what ECS is. So if you have your Docker image, right, where do I run it, right? So ECS is one of the services that AWS created. This was even before Kubernetes became as popular as it is today. So you have ECS where you can run any application on any container on there pretty much, right? You can run any container on ECS. So how? You create a Docker image, which, is part of the process. Once you create your image, sometimes you can just pull an official image from Nginx. Sometimes instead of creating an image, you can just put this information right here. You could just put this name, Nginx, as your image. Because it's public, ECS will automatically know that you're talking about the public Nginx and it's going to pull it for you. That's how easy it is. And then obviously you have to create a cluster. So we'll see some images that will kind of help to make you understand that cluster is essentially a group of EC2 instances. But the only difference is those instances have what we call a container agent running on them. And those agents is what deploys your images for you pretty much. So what I'm saying is cluster is a group of EC2 instances. The difference is those instances have Docker desktop running on them, which then enables you to be able to run images pretty much. So if you took an EC2, install Docker on it, you're pretty much creating an ECS, if you will. And then you need tags definitions. I hope you watch autoscaling. If you watch a video about autoscaling, you will see that we created launch templates. Do you guys remember launch templates in autoscaling? So in autoscaling, launch templates are essentially what you give your definition. For example, you tell your launch template how many EC2 instances you want, how many you want running at a time, and all those informations, your instant type, your AMI, and things like that, you put in your launch template. So task definition is basically that kind of blueprint, but then it's a blueprint for your images. So we'll see that in a minute. Looks like my Docker is finished downloading. Let me see if I can start it. Mona Lisa. Mona Lisa.
Do I need to sign in?
You might need to sign in. Do you have a Docker? Do you have a Docker login?
Yeah, it says Docker desktop starting.
Yeah. So you downloaded the desktop. So yeah, once you have your desktop, I just want to point out that the desktop is a very heavy application, right? It's not just the Docker itself. It contains even Kubernetes.
It takes a while to load up.
Yep, it's a big application. So yeah, just keep that in mind. So that being said, yeah, I'll give you all the privileges you need. So this is it. So once you start Docker, you're going to see something like this run. You see, my Docker is starting. So that's how you know.
I just downloaded mine. They say I can't use it on the version on my computer. I need a Mac 11 that I have a Mac 10.
Well, you should, maybe you can try to download the one that is this for Mac 10. Maybe you downloaded a different version. Did you download the one with iMac chip?
Yeah, I did the same thing when you were doing it.
You did the Intel chip.
You did the Intel chip.
No, I didn't do that. No, I did the one with the Mac chip.
The M1 chip.
The one with the one?
The M1.
Hang on, let me go.
That's
I did the one with Mac with Apple chip.
Yeah, you have to use the Intel chip.
I use the Intel chip? Okay.
Because the M1 is for the newer computers, like 2021 and up.
Yeah, you might be knocking and some of them work. I'm not even sure. Okay, so I have my Docker desktop running. So just a quick, if you wanted to check if your Docker was running, sometimes you can just run. So you can run on your terminal, you see, Docker PS. And when you run Docker PS, you're checking to see if there's any processes running. If you want to see if you have any images in your machine, you run Docker images. There's no images, so now we're good to go. So now Docker is installed and that's it. And if you're going to be a DevOps engineer, Docker should be your friend. So if I come and I do Docker pull,
Docker PS.
Are you seeing it pulling that image? It's pulling me the official Nginx image. So yeah, images. So now if I go back and type and say Docker images, now I see my Nginx is here. So I was able to pull it. To run it, we're gonna do all this when we get to the Docker class. As I'm just, it's good to always give you guys an intro. But once I put Docker run, all I have to do is provide the name of that image. Actually, it's Docker container run. You see, it's starting the machine. It's starting my image right away. So what is happening here is Nginx is another form of web server, just like an HTTP web server is, right? So what I'm saying is, with this Docker image, I have Linux in this image. And then I have Nginx in this same image. And then I have every other dependency that Nginx needs to run. And that's it, nothing else. So you have this light container that you can pull, you can push, you can move around, and you can deploy on any application pretty much. So this is exactly what it is. So you see, I have Docker running, and I have it running on my foreground. Most of the time, you want to run on your background. So I'm going to create a new tab, and I'm going to do Docker PS. And you see, it's telling me that an application is running. This is the entry point. It's been up for 51 seconds. Upstated 51 seconds. It's exposed on port 80, and this is the guy, pretty much the guy that maintains it. You know what I mean? So this is it. This is as easy as this. And I might not have to do some networking, but sometimes, I can go to my local host, and sometimes you can be able to go to your local host and be able to see your Docker image, your Nginx running. So sometimes you can be able to, is it 1.27? It's 1.27. So yeah, so if you expose, so this is it. To see your Docker image, you're gonna have to expose it. Once you expose it, you'll be able to see your Nginx being displayed. So like I said, we have a separate class for Docker. But as you can see, you have your Docker image container ID running. You have the image name. You have your entry point, which we'll talk about, and other information about your container. Let's see, another application, Docker logs. Sometimes you can look at the logs. You see that? So you can look at the logs. So these are some of the cool things you can do. These are the cool things. So anyway, you can look at the logs and see what it says, but clearly this container is running. The reason why we can't see it on our main port is because it hasn't been exposed, but you have this container running on port 80. As you can see here, TCP port 80. And port 80, remember port 80 is our HTTPD. So yeah, that being said with Docker, so let's go back to our ECR. So this is all, like I said, this is all DevOps stuff, right? So as a DevOps engineer, trust me, if your company doesn't have Docker, I promise you, they will be looking forward to getting Docker. So the company you're going to work for, they're either going to be using Docker or Docker images, or they'll be trying to use it. Because I mean, if you're not using Docker image, it's going to be so hard to have full agility. That being said, this is our ECR. Now I have Docker. I'm just doing it from scratch and see if I can authenticate. And if you're not able to authenticate, that's fine. Next class, what I plan to do next class is, to show you how you can set up your machine to be able to do all the command, everything that we've been doing on the UI, you'll be able to do it from your command line. So it'll be pretty cool class, because that's what I do all the time. It's going to look strange, but it's trust me, fun. You're going to be interacting with the API. So next class, I'll show you how you can do that. But today I'm hoping that we can be able to wrap up. So let me see if I can authenticate. I don't want to do it here actually. So remember the last class I told you how to download Visual Studio Code, just because it's so much easier for me to work with it. You see this terminal here? Can you see? It's the same as a regular terminal. So don't get confused. So this terminal is the same as this terminal right here. So don't get confused with it. So now what I'm doing is I'm trying to authenticate my AWS account. So now it's telling me, can you interact? So now we're having some parameter issues. So I'm not going to worry about it right now. I'm going to proceed with the class because this is just an added thing that I just wanted to show you. But yeah, we have our Docker image running, is built, and then it'll be as easy as just authenticating and pushing it to ECR, which I'm hoping that we can come back and do. So we're gonna go. So I want us to cover a little bit about ECS. So ECS, so this is an image of Amazon Container Image Registry. So we have our ECR that we just talked about, right? You have your ECR sitting here. Or it could be Docker Hub, which I just put an image Nginx from Docker Hub. That was Docker Hub where I put the Nginx one. So you could put your image from either Docker Hub or you can pull it from Amazon ECR. Obviously when you're working with company and company software, you have nothing to do with Docker Hub, right? Unless it's a private repository. So if you're working for a company, your repository will obviously be ECR. And then, because it's safe, it's secure, and then you can keep your code away from the public. So keep that in mind. So anyway, you have your Amazon ECR. And what happens is with ECR, you have what we call ECS. And what happens is you create your task definition, right? Your task definition, and then you create a few tasks. So we're going to talk about tasks, but the task essentially is an instantiation of your task definition. I don't know if that sounds complicated, but when you have your task definition, if I run one of my task definition with one task, it's just one instantiation. So what it's telling me, what I'm trying to say is your task definition can be reused multiple times, if you will. So each time you use your task definition, you're creating a task, and you can have multiple tasks running on ECS. And then you can have your service, and then your service is going to be what's going to make sure that your system is always running. Your service is going to take care of autoscaling. And guys, if you haven't watched the last video, I really recommend you watch it. You see what autoscaling does, because everything else on AWS builds off of autoscaling. Because without autoscaling, you're going to have very unpredictable applications, and you don't want that. You want your applications to be able to scale when the load is high, scale down when the load is low to save money and things like that. You want your infrastructure to be dynamic. So this is an example of a task definition. So now we're writing the task definition in JSON, but trust me, once we get on the console, you can be able to do it from the UI, and then the UI will be able to create a YAML or JSON or YAML like this for you. So what you're seeing here is a task definition. So what you see in your family is just a name, right? It's a name that you're going to name your task definition. And then once you go to your definition, you see your image, web, your name, web, your image, Nginx. So basically, this task definition you're seeing It's going to pull the same image I just pulled, right? Nginx. It's going to pull the same Nginx. You assign, you say, I want your memory to be 100, I want CPU to be 99. So you're giving your resource constraints. And this is important as you start working as a DevOps engineer, because if you don't give your memory constraints, if you don't say, okay, your memory, you can only use 100, you can use 99, what happens is some applications start hogging memory, hogging CPU, and then you start having spikes in CPU and things like that. I'm saying that from experience. So when you write building applications, Docker, make sure if you can give a memory constraint, always give it. You can give it with ECS. Once you do Kubernetes, you see that you can also do memory constraints. Today, my coworker, Scott, we were running an application and the application wasn't running. You know why? Because the application didn't have the right memory constraints. So we had to go in there, provide that application the right memory constraints for it to be able to run. So just keep that in mind. This is a very important concept. And require capability. Fargate is pretty much what we call AI in AWS. So Fargate is automated. Fargate will take care of your infrastructure and everything auto scaling. So Fargate is pretty much what you call like an artificial intelligence for AWS. So you can take care of your application for you. So you won't have to worry about how many applications I have running, how many I have done. Fargate will take care of that. And then you have more fine-grained constraints. You have a network mode. You say you want to install in the VPC, you want to use the VPC networking, which means that you want your application to communicate with any other application in your VPC, and then memory 512 and things like that. Anyways, and then there's tags and scheduling. So this is ECS in itself. Like I said before, a task is an instantiation of your task definition. I know this might sound complicated, but when we go and create a task definition, you see exactly what I mean. And then once you create your task and you off of your task definition, there's something called an ECS scheduler. You're not going to see it, but it's what's going to schedule your tasks on your cluster. And then you have now your service definition. Now your service definition will be able to tell your service that, okay, I have my Nginx web service running in this task. What I want to happen is I want to always have 3 of them running at one time. And if this load is high, I want you to have 8, and if it's low, so auto scaling pretty much. So your service will be making sure if any of your task dies, service will make sure it brings it back up pretty quickly. So it's managing everything for you. And some other important concepts, obviously, I just mentioned, auto scaling is highly involved in everything AWS, from Kubernetes to auto scaling. And how important is this? Is the fact that every DevOps engineer works on some kind of cloud platform, right? It could be Azure, it could be GCP, but mostly AWS. So now you can see that you are going to have to deal with scaling a lot. Load balancing, you can set up load balancing. We talked about that in the last class. ECR, we just talked about this. It's a registry where you store your containers. Cloud formation, we're going to talk about it. It's your infrastructure as a code. So we talk about it, don't worry. IAM, roles and management. We talked about that in previous class. So make sure you watch that video. And if you have questions, make sure you get back to me. So that being said, we're going to go in AWS and start looking at some of those tools that we just talked about. If you have any question, does anybody have any question? Any question? It's very important. If you have question, now is the time.
With this Docker, are we supposed to create an account?
Yeah, well, if you want to be, you don't need an account to pull an image or run it, but you need an account if you're going to be creating and pushing images to your repository, right?
So for right now, let's not create an account, just leave it as it is.
I recommend you create an account just because you're going to have to do practice with Docker. You're going to have to obviously pull and push. And if you get a head start now and create an account, when we start doing the official Docker class, you'll be ready. I don't want to, when we get to that level, I don't want to have to, start all over and start creating an account. So I recommend you creating and start understanding how it's working. It works right now.
Okay.
So yeah, this is ECS. So when you open your ECS on your machine, this is the first thing you see, right?
So Linus, how did you get there?
I just searched for ECS here. And then the first one that popped up. So this is ECS. So one thing we can do real quick is once you open your ECS and you get started, there's so many samples that you can see. You can see this is the Tomcat web server, this is sample app, and this is the same Nginx that I just put in my machine, right? So, and all of this will be deployed by our guy here, Fargate. So it will be automatically managed by Fargate for you. But if I just wanted to do a quick demo, I'll just do a quick demo so we can explain some of the concepts. So that is Nginx. So what we just created was our task definition and container definition. As you can see, now I'm doing the service. This is a quick way of doing it. Once we're done with this, I'll go back and I'll start creating step by step. So now this is our service. So what I'm saying is I don't want a load balancer. You know, I want my design. Remember, I told you that this is where you can see how many tasks you want running. So I can say, okay, I want 2 tasks running. So you're telling this Nginx service that you want 2 tasks running. So what's happening if anything happens to one of your tasks, this service is going to automatically create a new one. To put that into context, my company currently, we have most of our production workload, actually one of my companies, have one of our production workload on ECS, actually. So this, what I'm showing you right now, we have most of our production applications running on this application you see. And so I've had to work with it a lot. And one of the things that I took advantage of was this service that you see here. Now I'm putting 2 and I'm saying save. So we have, so it's just a story. We have an application that runs on this ECS that always sometimes will have high CPU, right? We have high CPU, so chucking the CPU is going to go to like 88, 90, and it's going to hang. So it does that all the time. And whenever it does that, you know, we have to come into our ECS, look for that service, right? Kill that instance, and then autoscaling will automatically recreate that instance. Once it recreates that instance, and then this service is going to automatically launch your. So once you kill that instance, this service is going to realize that, oh, I don't have 2 no more. So automatically creates new service and deploys to another instance. And then you have your new application running, right? And you have your new application running and you're good. So the way I did that was I did a little trick. What I did was I automated it using Python. So whenever I get an alert from Datadog saying we have high CPU on our ECS, the Python script will go in there, kill that instance, and autoscaling automatically recreate it. So this is a guy that takes care of that. So I'll kill that service, and the service guy will recreate it. So just keep that in mind. There's so many cool things you can do with AWS. You know, everything I'm doing, like I said, I'm teaching off of my experience. Remember, you want to get the concepts, you want to understand the concepts, you want to do a little bit of practice, but you're going to learn the most at the job, on the job. And you're going to learn even more when you're on the job and you're calling me and saying, I have this issue. How do we solve it? We walk through it. And then you even learn more. So this is a sample task definition that we just talked about. You see, it's a simple task definition. That's the name. Network mode VPC. You want to always have a network mode to AWS VPC. You see my container name is Nginx. My image is Nginx latest. So when I say Nginx latest, it's the same as just putting Nginx. But now I could come to this image and say, okay, I don't want the latest version, right? I want something else. So I'll come here and look at the tags and say, okay, instead of latest, I want the stable version, or I want the Perl version, or I want the mainline version, or I want this version. So if you want that, I can easily copy this and say, okay, no, I don't want that main version. I want a different kind of version. So I'll copy this and I'll come back and say, no, I don't want that version. I want something else. So I can quickly edit this. Oh man, the kids are here. The kids are here. So it seems like because we're doing this with Fargate wants to, make sure it controls, every granular part of that configuration. So we can do that here. We can say custom, and this is what I can put and say no. I want my Nginx mainline. Or I can say, okay, no, I don't want mainline. I want a different version of Nginx. I want Nginx 1.21. So I'll come here and say, okay, no, I want Nginx 1.21. So just keep that in mind. And the reason why this is important is because sometimes you can have application pinned to a particular version, right? When you're using ECR, you're going to build images each time. So when you build a pipeline, each time you do a deployment, you have to build a new image pretty much. So once you build a new image, you're going to tag it. So this you see here is a tag. So this will make sure that you're running that specific version that you built. You don't want to run an application with an older version, or you don't want to run an application with a newer version. You want to run with a particular version that you choose, a particular version that you want to sell to your customers, right? A particular version that you want. You don't want any random. But if you put latest here, it means that each time you put Nginx, it's going to go here and just put the most latest one, right? And that latest one might not work with your application. You get the idea? So that's basically why it's so important to always specify a tag when you're using images. So anyway, now that makes, I hope that makes some sense. So I'll just go back with my own Nginx and just launch this application. It's launching. So that being said, any questions?
We're not using this Docker app today, right?
No. We're not using it. There's actually a separate class for Docker.
All right.
But once we get to that class for Docker, you already have this idea, right? You already know what ECS is. You already know what EKS is. So it makes things a lot easier.
All right, good. It's just the app's not working. It won't start.
Your Docker?
Yeah. It just says desktop starting, but it's just been saying that for like 10 minutes.
You have to restart your machine.
Oops. Yeah, we don't want to do that right now. Anyway, yeah. So we're not going to do any Docker. So everything I'm doing right now is practicals, explanations, right? And then now you can go, once you rewatch the videos, you can then do your practice, right? Because if you can try to follow along, but you might really take you away from what we're trying to do here. So now we have this service application running here. We have this service running, and Fargate is going to take care of everything else. So let's go back and do this whole process again manually. So if you wanted to do this manually, you first of all create your cluster, right? So what I'm doing is, you see, you can also create windows. You can create your networking only, your VPC subnets and things like that, and then Fargate will take care of the rest. Or you can do your EC2 Linux with your networking, right? So I'm just going to do this one because it's the most granular one. So I'm creating my cluster. It's easy, just create a cluster name. I'll name my VPC on demand, and then this is where you do your instance type. Your instance type, what kind of instance do I want? So I'll just go ahead and say I want the free ones. I want T2 micros. Well, actually, we don't have any T2 micros here. I don't want to pay any money. Wow. Anyway, I'll take C4 large. How many instances do I want? I want one. Actually, I want two. And then this is your AMI. Your AMI, your root EBS. This is how much volume you want in your system, your EBS volumes. Your key pair, I already have a key pair. Remember a key pair from last class? And then it comes to your VPC configuration, right? It is going to create a VPC for me. So you see, it already has an automatically filled CDR block, subnet 2, and others have already been automatically filled for me. And then for my security groups, you see, you already open port 80, which means that if I'm launching a web application here, my web application I should be able to access it pretty much. So anyway, that's it. That's how you create your cluster. Once you create your cluster, remember your cluster is just a bunch of EC2 instances that can run Docker images pretty much. So don't get it confused. Your cluster is just a bunch of EC2 instances that have the Docker daemon running on it, which means that now you can run Docker images on them pretty much. Like now, this local machine I have, right now, this is an ECS cluster. Why? It's not a cluster, it's an ECS machine, because now I can run Docker images on it, right? Remember, I can run Docker, I can check. So Docker is running on my machine. So this is basically what I'm building here, but I'm building a bunch of them, a cluster of them. I'm building 2 of them. they all have that image, so they can all run Docker. So that's all what it is. It's nothing complicated. And then now we go to our ECS. So it looks like Fargate finished creating. So you can always see your ECS here. I see we have one service running with 2 running tasks. And you know what those tasks are, remember? The 2 running tasks we have, the Nginx service that we have running. So these are Nginx. So we already, this was the first application we ran. We have our Nginx running. And this is exactly what I see mostly almost on a daily basis. We have the same ECS running our application workload. So this is an important concept. You have to just understand it. Most of the times you go on the interviews, having an understanding of this probably help you a lot. And once you understand it, doing the practicals will be nothing. So let's look at some common features here. This is our task. These are our 2 tasks. Remember when we did the service, I said I wanted 2 running at the same time. These are our 2 tasks. So if something happens to one of these tasks, it's going to be automatically recreated, right? You can stop it, you can do anything you want to do to it, and then it will automatically recreated. You see what it says here? So what it's telling me is if I stop this, my service will automatically recreate it. Why? Because my service is not going to know that I stopped it. It's going to think that, oh, I'm supposed to have 2 tasks running, but I only have 1. It's going to automatically recreate 1. So that's just what it's saying pretty much. So yeah, we have our service running, and we should eventually do a demo and see how we can launch applications. Most of my applications, I've used infrastructure as a code to run many applications here on ECS. But that's basically what it is. Like I said, it's not rocket science. It's just running the Docker image. You see the Docker pull Nginx. This is the same thing. We're just running Nginx. That's what we're doing, And you have many companies that run their workload on ECS, just like this. Yeah, just like this. And some of them don't even have it in code. They do it like manual, like click, 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 and then they run it. Pretty much. So that's what it is. So remember, when we did the service, I did not attach a load balancer. So because I did not attach a load balancer, we might not be able to access that service. But you see, you even have your metrics, the system metrics here. If you were getting any hits on that application, we'll see it here, obviously. And if you want to look, I remember I told you a cluster is a bunch of instances that are running, right? Bunch of EC2 instances. So now, the reason why we're not able to see our instances here is because it's controlled by Fargate. And Fargate is an automated service. But we will be able to see our task and we'll be able to see our service right here. Anyway, so that's just our Nginx running. So I'll go back to our manual one that we created. This is our manual cluster we just created. It's called the DevOps cluster. So if I go back to cluster, you see 2 clusters. You see the service cluster that I created with Fargate, and you see the manual one that we created. The next thing we want to do is we want to create a task definition. So my task definition, this is what we did previously. We use Fargate. So Fargate manages, you see, Fargate manages your infrastructure and it manages your instances. That's why we couldn't see those instances. Most of the time, this will be the best option. If you're in a company where you're just 1 person or 2 person, you want to use Fargate. So Fargate will manage everything for you. Just keep that in mind. But then, if you're like me, that I like to manage everything on the granular level, I'll use the EC2 because I like to see everything. I like to manage everything. I'm very controlling my application because, because if anything happens, I'll be able to troubleshoot. So this is my task definition. I'll call it DevOps. See, I already created a row previously, so I'm just going to use that row. But if you didn't have a row, you have to create a new one. Remember, we did IAM. IAM is where it manages a row. Everything you do, like I mentioned, if you watch that video, I mentioned that everything you do on AWS, you need a role for it, right? Everything you do, you have to create a role. And all that is done using IAM. So keep that in mind. So if I needed a new role, let's say I didn't have any role here, and I wanted a new role, this is where I'll come and I'll do it. We already have a video for this, but I'm just running down just a refresher. You come to IAM, and this is where you're going to create a role. You see, you come to roles, and then you create a new role. And then you're going to say, okay, what service does it relate to? So now this, what the service I'm trying to target is ECS, remember? ECS. So you see we have EKS and then we have ECS. So with ECS, most of the time when you want to provide an ECS rule, since you don't have ECS here, you can use EC2. Because if you have access to EC2, you also have access to ECS pretty much. So we have EKS. I know we might have, okay, this is it's actually right here, Elastic Container Service. So I'm just going to choose that. And then what's it saying? The role for Elastic Container Service. Yes, that's what I'm looking for. Auto scaling. I want the entire row. This is what I'm looking for. And then that's how you do it. And you create a row. Once you finish creating a row, this is it. Next task, and then you just create that row. Next task, review, and then you give the name of the row, test row, ECS, and this is how you do it. And then create the row, and the row is automatically created. Now, when you come here, if I refresh here, I should see my row, my new row there. So this is so you can refresh. The row has been created, test ECS. So normally, yeah, I'm refreshing and I'm expecting that I see my row. I'm not seeing my row, so I'll go back to previous and I'll come back and see if I can see my row. My row is not here, so I'll just use the one that I created previously. But yeah, you see, it's even giving you a link. And when you click on that link, it takes you directly to where I was and where I created that row. And this is my row here. And then the row that I created that I'm using right now, this is the other row. And I created this row, I think yesterday. This is a row I just created. So it takes you here and you could do the same thing I just did, create a row. So yeah, so once you create that row, normally when you refresh, your row is supposed to appear. But for some reason, my row hasn't appeared, so I'll use the one that I created yesterday. Network mode, you want an AWS VPC. That's important because you want if you want your applications to be able to communicate with each other, you want the VPC. And everything else, task execution row, there you go. We have row, and you see here, you can be able to create a new row. You can be able to create a new row, or you can just use your old row that you have. And this is where you give your memory constraints, right? You want to say the size of your memory. I want you to have this, and I want you to have this. This is where you put it, your memory. And then this is where you add your container. Your container information. So my container name, I'm just going to go back and say, I want to run Nginx. Or I could come back and say, no. How about I search if we have Hello World image? Okay, I want to use Hello World. So I'll say, okay, no, instead of using container image, I want to use my Hello World application. All right, so I'll use my Hello World image. And you see where I'm pulling that image from. I'm basically pulling that image from Docker Hub. So it's a public image. So if you push your image, when you create an account and create and push your image, you can come here and pull that same image. That's how easy it is. You just put the name of your image, and then it's gonna automatically pull in and run for you. That's how easy it is. Anyway, yeah, you want to provide a hard limit or soft limit. This is where you do it. Remember, I always put these things. Right now I'm not doing it. If it was a private repo, you have to obviously put some kind of authentication. But fortunately for us, this is not a private repo. This is a public, so we don't have to put any kind of authentication. And then you can put a health check. And a health check is something that you want to make sure that before the container runs, it's going to run that command, right? As you can see here, this is running a curl, and it's curl to a host name. So you could say, okay, I want you to curl. Let's say I have walmart.com, right? And I'm running multiple images for walmart.com. The way you can do your health check is you can say, before you start that image, I want you to curl walmart.com. If you don't get a response, right? If you don't get a response image of this main page that you see, if I don't get Walmart department service, if I don't get that in an HTML, then know that the application is faulty. I want you to report that application as broken. Keep that in mind, it's a very important concept. Whenever you build an application, most of the time you want to have a health check. And your health check is going to make sure your application is actually running before supply. Imagine, your e-commerce website, you're selling shoes, or a Walmart, and then you start the application without the health check, without checking it. You might have an application that is running, and if your health check, you don't have a health check, you're going to lose a lot of customers because customers can't access your website. You're going to be sitting chilling and thinking you're making money. and then you look at your balance and there's no money, and you wonder why. If you had a health check, your health check will be able to pick that up real quick. So, so let me do a quick health check here. So curl, you have to make sure you have curl on your machine. So curl is like an API command. So when you get into DevOps, you're gonna love curl. So with curl, you can pretty much curl any website, right? And it's going to mostly, sometimes will give you that web page. So you see, apparently Walmart is blocking, because with curl, you can do API calls, right? So let me see if I can curl google.com. So this is a nice command for you to have. You see, I'm calling google.com, and it's giving me exactly what you would see if you were to go on google.com. So let me just show you what I mean real quick. Google.com. You see this page? This is exactly what this is, but it's just giving you the page in HTML. And if you want to see what HTML looks like, I'll give you a quick example that I have in here. Let's see. This is a quick example of a simple HTML that I took. This HTML is a simple page. I have another one. Where is it? I have another HTML. It's right here. This is another HTML. Let me close this page. Oh, my terminal is all the way here. So this is another HTML. It's basically, you have your H1 is your header. Obviously, it's going to be your heading, so it's going to be bigger. And then your P stands for paragraph. So it's so easy to write a static application with HTML. Some people are used to HTML, but this is basically what's going to come back, and you're not going to have an image. And this is a Docker file that I intend us to build today. So I'll show you how to build this Docker file. And once you build this Docker file, once you build the Docker file, we'll essentially be building this image that we can be able to deploy. Yeah, so that'll be the last tutorial. I think it'll be fun because we're going to do the entire pipeline. So that being said, that's what the health check does, right? As you can see here, this health check has the local host just to make sure that it gets a response. And then, you have your environment, timeouts, and all that stuff. So when you run your production application, obviously you want to take somebody seriously. Like for example, networking, host name. You want your application to have a website like walmart.com, right? This is where it goes, walmart.com, your host name. And then your DNS servers. For Google, you see 8.8.8, mostly that one is associated to like Google, 8.8.8, and things like that. So you can do all this manually, or you can do all this with code. You see security, resource limits, and all that. This is where you put everything. So there's some of them that I'm missing. Pod. I want my application to be exposed on pod. Let's look at that real quick and see what it says. So this is essentially what I'll do. When I'm running Docker images, I'll come to the documentation, I'll go through it and I'll read it. I'll say, okay, how can I run this Docker image, right? Is there any particular pod that I need to be aware of? Is there any particular pod that I need to open? But for this one, essentially it looks like, pod 80 will do the trick. And you just do Docker run hello world, and it's going to display this image to you. So before we do that in a local, in console, I want to do that in a local real quick. So remember, this is as simple as saying Docker pull hello world. And it's just going to pull that image that has my hello world application already running on it, right? You see, it's pulling it. And then to run it, it's as easy as Docker run hello world.
You said container run. It's just Docker run.
Yeah, Docker run or Docker container run. Before it was Docker, you can use Docker. Sometimes I tried Docker run, it doesn't work. But it looks like the new versions of Docker, you can just use Docker run. Docker run, Docker container run, the same thing. So you see, this is my application. You see this? It's exactly what you see here. So that's how easy it is. You just pull the Docker image and you can run it. So you could, just like you could run this application, that's how you could run pretty much any application that you have it Dockerized. It's not rocket science. That's why you have to understand this concept. So this is my Docker application running here. My Hello World application is already running. You even display this image to the screen. So yeah, so that's it. You already ran that image. So if you pull this image and run it, it will display the same image. This is what's in the Docker image. And the way you create Docker images, you create them using something we call Docker files, which we're going to go through when we're doing the Docker class. So, but these are ready-made images. So let's go back. Where was I? My ECS. So this is where I'll say, okay, I want it to be displayed on port 80. It doesn't, in this case, if I'm running hello world, it doesn't matter that much. Is there any other important aspect I'm missing? Let's see, tag, hello world. Let's see, what else am I missing? I'm just hoping I can put just what I need, just a sub limit. Let's see. All right, I'll put the sub limit of 128. It's not a private repository. Is there anything I'm missing? Let's see. TCP will work, and then that's it. So this is a basic container definition. But then, like you saw this advanced, like putting a health check. When you're working for a company, you want to use some of these tools. You want to use some of these, like you want to put labels on your image. You want a health check. Like I just told you how important a health check is. So you want a health check. Health check could be anything. Sometimes I've written a health check as easy as putting a file in that machine and then seeing if I could cut that file. If I can't cut that file, and then I know that machine is not up and running, right? That's just common sense. So you can be creative around this, around how you create your health check. So just keep that in mind. Anyway, yeah, there it is. So we have that. So now we have the name of the task definition, EC2, the role, the networking, the task, the role. This is where they had memory, and then we just added the container. Remember, we added hello world. And anything else we're missing? Let's see. And then now you can put your tags. I can say name is hello world. And let's see if we can go ahead and create this real quick. So tag definition, it says it's been created successfully. So if I come to tag definition, I'll see two. This is the first one we created, and this is the one that I just created right now, the new task definition. And now remember, when you're trying to run a task is an instance of this task definition, which means that I could run this task definition multiple times on multiple different containers, and it's still going to produce me the same outcome pretty much. That's what it is. So yeah, so we just created our first task definition there. Now, once you create the task definition, now you're good to go. And now I can always come back and say, okay, I want to go in here and I want to, I already have my task definition. I want to create a task, and then you can just continue consuming that task definition. So let's see, launch type EC2. You see, automatically it's able to pick my default task definition, but I could use the previous one that I used. So now you see the difference. You see that task definition, you can use those multiple times, and you can go back and forth between any task definition. If I use this task definition, it means that I want to run the Nginx server. If I use this DevOps, it means I want to run hello world. You see the difference now? How you can start using those tasks. That's how you use the task. And then the cluster, I can say I want to use a service cluster, I want to use a DevOps cluster. It's so easy. Guys, these things are so easy. It's not rocket science. I keep telling you. None of this stuff is rocket science. And now I want to create my service. DevOps service. Service type, replica, number of tags. So if I put 3, remember I told you, if you put 3, my service is going to make sure that I always have 3 services running. Keep that in mind. If I put 2, my service is going to make sure that I always have 2 services running. So if one service goes down, this guy is going to go back and create a new one. Healthy threshold, they have to be 100% healthy. I don't want any. So that's why so update, deployments, keep in mind, you have to get used to the word deployment if you want to do DevOps, or be in the cloud, or be in DevOps. Deployment is basically, you're pushing your application out there to the public. That's what deployment is. And how do you want to push your application out there to the public? You want a rolling update. The rolling update is basically, once you kill one application, you bring one up. You kill one, you bring one up. Blue, green, keep in mind, guys, I want you to keep, this is a very important concept. I want you to keep this in mind. And if you can do more reading on it, you might get that in an interview. Most interviews I go, they ask me what's the blue, green. And blue, green, essentially what happens is you have 2 environments. With blue, green, you have 2 environments. You have your blue and you have your green. So what happens is you have your own environment, which is your blue, and then you have a new environment, which is your green. So what happens is when you build your new environment, which is green, the green, what happens is your green takes the place of your blue. So it's like a swap. So when you have your first application, when I'm building the first application, it's going to be blue, and then my old application will be green. And then when I'm ready, and then I swap it, now my blue is now green and my green is now blue, which means that my old application has replaced my new application. And that happens, and the key you have to remember is that happens instantaneously, and that happens only after your blue environment has been validated, it's passed its health check. Once it's passed its health check, so for example, if I had 2 tasks running and I did the blue-green, it means that my new task that I'm deploying is going to make sure that I have 2 tasks, and it's going to make sure that those 2 tasks are running. Once those 2 tasks are running, it's going to swap, and the blue will be in the back end, and now the new application now will be the green, which consumers can now consume. So it's a lot of advantages to blue-green. You know, obviously you can see a disadvantage that you have multiple instances running at one time, and then once your green is running and it's serving, it kills the blue application now. And so that's what blue-green deployment is. So, but you know, I'll just do a running update for now. That's a very important concept. I just say, but keep in mind, if you're doing DevOps, you want to know what blue-green deployment is, because I've done a couple of them, you know. So you want to know what the blue-green deployment is, because companies will ask you, you know, what kind of deployments are there? You know, what is blue-green deployment? You know, what is rolling update? You know, what is, you know, canary deployment? You know, so keep in mind. Oh yeah, so that being said, I choose rolling update. I'm just gonna choose some random subnets. Security group, we already have one security group here. You know, see, you can edit the security group. So I have HTTP open. I can add SSH so that I can be able to go into my system and do troubleshooting. Let's see, where is the SSH? There's no SSH. Oh, SSH right here. So now, the good thing about adding SSH, if there's anything wrong with your instances, you can log into it. You can SSH to it like any other instance. So I want an application load balancer. And I'm going to give the name of the load balancer. Please. Oh, it wants me to create an application load balancer. I thought you were going to create a load balancer for me. Anyway, yeah, I think it'd be nice to create a load balancer just so we can expose our service. I know we did a class before on the load balancer, but you know, the more views you see with AWS, the better for you, obviously. So let's see. Load balancer name, test load balancer. Internet facing, I'll just put in multiple subnets. Normally we could do that without creating a load balancer, but I'm just showing you, you know, so that's load balancer, you know, security group. I'm just going to use a default security group. Obviously it has to be port 80, and we don't have any target group right now. That's the issue, right? Because you want the application and the target group. The reason why we didn't have any load balancer, because your target group has to be this instance, your cluster, right? Your cluster is your target group. Your issue. So we could create a target group, and the target group, well, if you create a target group, we want to create a target group that's going to target those clusters that we just created. So let me show you real quick. So now we're going to go to our instances, to our VPC. And when you look, you see, there's an ECS VPC. This is VPC, and there's a DevOps VPC. So our target group obviously has to be a DevOps VPC because that's what we're using. That's the DevOps VPC. That's what we're deploying. Test DevOps. And then hopefully we're going to see some instances, ECS instances that are running in that target group. Hopefully we're going to see some instances running. Let's go back. I don't see any instances. Let me try. What other? Let me see. Let me check our ECS VPC guide. Let's see if we can see any instances running. Normally, remember when we did the scaling, when you have instances running, you're gonna have a load. You're gonna have a load here. So let's go back to our clusters here. Now go back in DevOps. See 2 instances, and we have 2 instances here. So these 2 instances, these are the instances that if I wanted to create a target group, this is where I'll create my target group to target. Right? So this is the instances that if I create my load balancer, I want my load balancer to target these instances because this is where my application is running. That being said, where is it? Sorry guys, if I keep bouncing along, there's just too many tabs open. So what do we have here? We have our HTTP test group, we have our test target group, and then we have, so I'm not even sure which one we created. Well, I think this is the one we created. So now we have our load balancer, and now I can just say, okay, which load balancer am I looking for? I'll reload, and then I'll choose my load balancer. So I'm waiting for my load balancer. For some reason, normally when you're using AWS, most of these services, they come out when you reload, they come into use pretty quickly, you know. But today we created the row didn't appear pretty quickly. We created the tags didn't appear pretty quickly. But essentially, this is what obviously your tax definition will look like. You have your name of your tax definition, your name of your load balancer is internet facing, IPv4. You have your default security group. You have your networking. You have your listeners, and this is where your load balancer listens to. So when you hear about listeners, what it's telling you is my load balancer is going to listen on port 80 on that application running. And sorry guys, there's no other way I can use these languages. I just have to use the IT languages. Just because one, there's no other way for me to explain this, and two, if you want to be doing IT, you want to be hearing the languages, right? You want to get familiar with the lingo of IT. That's why I keep using these IT languages. You know, you want to be used to the lingo. So if you go in there, because they have to pretty much tell someone that's not a good engineer by the way they talk, pretty much. If we have yeah.
I have a general, like a very huge question though. Yes. Okay, what's the purpose? Let's say you're working, like say in a work environment. What's the purpose of creating all these, these tasks, all these EC2 instances, all these, what is the purpose for creating all those things?
Because, the first thing I'll say is, the first thing I want to say is, when a company hires you, right, they hire you so you could do a job, right?
Yes.
And how do companies make money? Companies make money by having customers, right?
Yes.
And let me give an example. I'll go back to Walmart.com. For Walmart.com, for me to be able to go to this Walmart.com and shop, this Walmart service has to be running somewhere, right?
Yes.
And this is basically what I'm showing right now. You could run a Walmart.com on an ECS service and be able to display it to your customers. So the reason why you're creating this is because, if a company wants to make money, they need a way to be able to, meet their customers and supply the application. And this task definition, this ECS we're creating here is a way for you to create this web page where customers can go in there and shop and buy things, and so you can make money pretty much. So the helloworld.com is this essentially a Walmart.com, but it doesn't have all these complications. So you get the point?
So one question, each instance is basically a page on the Walmart.com. That's what you're saying?
When you say instance, what do you mean? You mean those EC2 machines are created?
Yeah, the EC2 machine.
No, the EC2, those instances, what they're just servers, right? They're just basically servers. For example, this laptop I'm using right now, right? This is just a server. Whatever I do with this laptop, that's my business, right? But now, with AWS, with these particular instances that we have, the business is to run helloworld.com. You get it? But you could have used that instance to do anything. You could use that instance to run GitHub, to install GitHub, install HTTPD. You could have used that instance to do anything that we did last time with our EC2 instances, right? But our purpose for this is to run helloworld.com. Just like if you go to Walmart and you're working for Walmart and you have to manage, let's say, an ECS cluster like this, the purpose, your goal, obviously, will be to run Walmart.com, and those instances are just what is helping you run those applications, right? It's just an enablement. It's just a server. It's just where you can install and run your Docker image. It's just a workhorse, pretty much. Let me put it that way. It has nothing to do with the web pages. The web pages come from the code.
Okay, so the web pages come from the code. What about when somebody clicks and like buys something? Like, where does the backend come in on your side?
The backend.
Where do we like DevOps engineers? Where do we come in?
So you come in because you manage all of this, right? You manage the ECS cluster, and then when you come, I know Alpha talked about backend. If you have a typical application, it's going to be a typical application is always a tweety application, right? You have something like this, which is internet facing. Your load balancer, right? It's going to be pointing to those Hello World applications or just Walmart.com applications, and then those Walmart.com applications will be connecting to a database. Remember we talked about RDS?
Yeah.
Yes, so those Walmart.com will communicating to a back-end database in RDS, which you're going to create, same, just like you're creating this. You're going to create the application. For example, if it's a Java application, in your Java code, you're going to use something we call, if you're using, let's say, Postgres, you're going to use a Postgres SDK. Trust me, it's going to be complicated, but you're going to use something called an SDK in your code. And what the SDK does is it gives you access to be able to connect to any database as long as you have access, right? Yes. So now with that SDK in your code base, no matter where you deploy your application, you'll be able to find that database and connect. You get the idea?
Okay, I think I get it. So this EC2, the ECS service is basically configuring the network, like what point to what? Is that what that is? Like if somebody is coming into Walmart.com and they're coming in from the internet and you have port 443 open, then they have the access to come in. But if you don't have it open, nobody can get into Walmart.com.
Nobody will be able to. We'll be completely blocked.
So you're just controlling the access in and out on the back end. That's what ECS is.
Remember, no. You mean ECS?
Yes.
Remember, ECS, I think my bad, I might not have done a good job explaining this. But ECS is a container orchestration platform, right?
Right.
What I mean is, remember, your container has all your application running on it. Remember, right?
Mm-hmm.
If I was running Walmart.com, I'll have a container that has all the Walmart code packaged in that container, right?
Mm-hmm.
For the case for Walmart, I don't want you to get confused, but for the case for Walmart, it's not going to be just one Docker image because Walmart is such a big website, right? In the case of Walmart, you could have multiple Docker images serving different purposes, right? But it's all the same concept, right? So if I had Walmart.com, if I was managing Walmart.com, this guy you see right here, this would be a complete Docker image on its own because it'd be a microservice, right? Just because you don't want to pull all this application, you don't want what we call a monolith. The reason why a DevOps engineer is you don't want what we call a monolith. A monolith is one application that has everything in it. You know why you wouldn't want a monolith?
The break.
Just in case one fails, it doesn't.
Exactly. One fail doesn't, and it doesn't bring everything down. If you have a monolith, if you want to change one thing in the application, right, it means you have to bring everything down, right? But now, if I have a microservice for my cat, and this cat is able to communicate with the other applications, it means that if my cat service is down, I can go in and quickly fix it and push it. But then all the other parts of the website will work.
Okay.
Exactly. So this card itself will be a complete Docker image. And then you could take that image and you could run that image here on ECS. And then how is your application going to know how to communicate with each other, right? Like, how is your card? How is your Walmart when the customer comes and adds this into their card, right? How is this card? How is this going to know where to put this in the card and check it out if they're not all running on the same image, right? That's where the code base comes in, right? Each microservice you run is going to have an endpoint. It's going to have an internal endpoint. And then you can point your application to that endpoint. So each time it needs to check out the card, it pushes it to that endpoint and it automatically comes to this guy. Like today, I was doing a migration today for our company. What I'm doing is I'm working on part of our website called group gifting. So maybe it'll be easier if I show you what that is. Maybe it'll make more sense if I show you. So this is essentially the page that I was working on. So I want to go on the group gifting. So I was working on just this page, this exact page you're seeing here. This is the company website. I was working on this page. So what I was doing is this page you see here, It's a complete microservice on its own. So I'm able to create a Docker file for it. I'm able to test it, and I'm able to run it. And this page you're seeing here is running automatically in Ruby, right? So if I come here and say group gifting and giving gifts and all that stuff, I know it wants me to sign in, but this is a page I was working on, just the group gifting page. And you see you can give a gift to a customer and everything. So this page you see right here, I was working. So I created this a separate Docker image for this, just for this page itself. So when the customer comes on the website, right? If a customer comes on the website and say, okay, I want to give a gift, right? I'm looking for a gift. And they come, let's say they look at the categories, the gifting, right? As soon as they click here, it takes them automatically to this page. And this is the page that I've been building and testing, right? So if I wanted to update this page, I'll update that Docker, I'll update the code, build the image, and I'll deploy that image, and I'll just replace this old image. So you get the point now?
Yeah. Also, these images, like these images we are seeing right now, you just took them from somewhere else and then, put them here?
Yeah, I took them from our entire code base. I built it in a Docker image, and then I deployed that same Docker image, and that Docker image gives you this. So you could basically do the same thing on ECS. I could take that image, run it on ECS, and it give me the same output you see here. But guys, I just want to say this is entirely written in Ruby. But I was working on this page the entire day of today, trying to build it, trying to test it, and get it to run. Why? Because I'm trying to migrate this from Heroku to AWS, right? So I'm creating entire Helm charts and all that stuff, and I'm supposed to run it in Kubernetes, right? So what you're seeing is soon, maybe by next week, this page you see here, you see the same page, but it wouldn't be running in a completely different server. So you get the point now, Alpha. You're asking me what those EC2 instances do, right? They're just there as workload. So what will happen is I'm going to migrate this page from Heroku to AWS, and I'll just be running on a brand new set of instances, right? On Kubernetes. But you still come here and you still see the same thing. Why? Because I'm just packaging that Docker image and deploying it in AWS from a different cloud platform. So that's basically what I'm going to be working on this week. Moving this page from Heroku to AWS, and if there's any new changes made on this page, I've also already built the pipelines using Jenkins, and Jenkins will automatically update this page. So guys, I'm giving you real life knowledge. This is exactly, this one company I work for. This company is essentially, it's a kit Montessori company. So they sell kits to all kinds of goods. So yeah, did that help?
It does help, but it sounds really hard.
So let me get into a quick question.
Go ahead.
Yeah, so you're working Heroku to so you're kind of pointing the Heroku server to the AWS server. That's what you're saying, right?
No, Heroku is a complete different cloud platform, right? It's completely different from AWS. It's like okay, how can I say? It's a completely different company. It's a competition. It's like Walmart and Amazon, or Walmart and Costco. But now we want to move because it's too expensive, right? So we want to move them from Heroku. In fact, essentially, it's like you want to say, okay, I don't want to buy from Costco anymore. Now I want to start buying from Walmart, right?
Yeah.
So it's a complete migration.
I understand. It's like taking your your goods from one storage facility and taking it to another storage facility, which is cheaper.
That's exactly what I'm doing.
But it's gonna be the same product, but you're just moving from one facility to another facility.
Exactly, and that's why I keep telling you guys, Docker images are so important. You know why? Because that same Docker images that I was running on Heroku, once I'm able to test, build my Helm charts and all that stuff, I'll be able to pick that same Docker image and deploy it in AWS, and it's going to provide me the same information.
Oh, I see.
Yeah. So anyway, yeah. So,
but is that what like a DevOps, let's say a DevOps engineer, is that what we're going to be doing like every day at work, or is
no, not every day. Trust me. This is just you. This was a hard task, but you might have to do that every now and then. But you won't have to migrate all the time. No, you won't have to migrate all the time. But yeah, you don't have to. But yeah, anyway, yeah. I really
basically, I was just, since we've just been learning how to install stuff, how to work on stuff, so I just want I just wanted to get the idea, like, okay, all this stuff we're installing and we are learning, how are they going to help us? Like, what are we going to use them for?
Exactly.
Yeah.
Are we gonna, you said we're gonna do a project, right? Like build something?
Yeah, obviously, it would be a disservice if the end of this class we don't build. But even in this class today,
That will help.
Yeah, at the end of the day, we're going to build an actual project. But at the end of this class, I plan to do like a CI/CD, like a pipeline, right?
Okay.
So you can see how a DevOps pipeline works from start to finish. So I plan to do that. So we can go for a break, and then when we come back, we can continue.
So I won't be able to stay. Okay.
So good, man.
Yeah.
You can do whatever you want, bro.
Yeah, can I jump in with a quick question before we?
Yeah, go ahead.
Yeah, so this web page that you're presently working on, so the theories you just explained today, yeah, actually applying all those theories like load balancing, auto scaling, tagging the various versions and stuff. Let me just understand.
Yep, everything.
All
so
right.
If you want to again, in fact, let's go ahead and try to do it again one more time. So remember, the first thing you want to do is you want to create your cluster, right? That's going to contain the EC2 instances that you need your application to be running on. Remember, your EC2 instances, they can be 10, they can be 20, but if you have lower EC2 instances, it limits the amount of Docker images that you can run, right? So keep that in mind. So it's just a bunch of EC2 instances. Let me try to explain that again. Do I have any EC2 instances running? Check. So when you create your ECS cluster, you're going to basically create a bunch. If you say you want to create two, you're just going to create two instances similar to this. But the only difference is those ones are going to be able to run a Docker image. But this one cannot run a Docker image unless you install Docker on it. Do you get the difference? I think that's a big difference. So let's say I want two instances. So what I'm saying is I want two EC2s here. So that's basically what I'm saying. I want two EC2s. And then this one is automatically telling me to create a VPC. But if I don't want to create a VPC, I could just use a default VPC. On the most part, you want to, I'll just use a default VPC. Let's see, where is, like I told you, it's so easy to find everything on the console because you can just search here and it pops up pretty quickly. So I'm just trying to look at the VPC ID for my default VPC. So to know which one is the default, you see, let's look at this one. So we have one of these VPCs were created manually, and one of these was default. So when I look at it, I'm seeing that this one is the default VPC. Normally most of the time we tell you, but the best way to find out is for default VPC, you're going to see at least, you're going to see at least 6 subnets. So if I were to open the subnets, you see we have 6 subnets. So to be able to find subnets that belong to a VPC, you can just search the VPC ID here. And so, yeah, so that's our default VPC. That's the one I want to use. So I think is this one. Then I'm just going to use multiple subnets. And if you notice here, it's not giving us a public subnets for some reason. If you notice, it keeps giving us a private subnets. It's because by default, it's trying to protect your workload. Because if you have a workload, you want to run in the public, you want to run in the private, and then have something like a load balancer or something, actually propagate your load. So, but yeah, if I hit enable, it means that all of them are going to have, eventually have, you see, now you can have, now you can use multiple, so there's multiple subnets on here because I enabled my public IP. So you really watch the VPC video, you see this. Security group, I'll just use as the default security group. There's an instance role there, and I'll just go ahead and create my cluster real quick. While my cluster is creating, I'll just go ahead and, because we have a lot more slides to cover, while that cluster is creating, I'll just go ahead and talk about the slides. So this is another service that will be a direct service we don't talk about. This one is the EKS. So it's basically just like ECS. The difference is this one is strictly Kubernetes. So it runs the Kubernetes application. So when we study Kubernetes, which I think we're going to study Kubernetes right after we study Docker. We're going to talk a little bit more about Kubernetes, but I just wanted you to understand that Amazon also has a Kubernetes service that is managed. The advantages of managing a Kubernetes, if you haven't read about Kubernetes, I know a few people contacted me asking me about Kubernetes, but if you've never read about Kubernetes, if you have to run your own Kubernetes, it's a lot of work because you have a control plane to manage, and this control plane is essentially what controls your application. And this control plane includes all your controllers, your scheduler, your horizontal port of the scaler, and all those controllers are controlling your app. So, I'm just saying, so it's complicated. So when you have EKS here, Amazon will be able to manage all that for you. So I'm telling you guys, everything is so easy. As a developer, now you just have to put in your own work and study a little bit. But they pretty much done everything for you. Now AWS manages a control plane. You can easily integrate with other services. So EKS can integrate with ECR, with your Docker image, and with your CloudWatch, with your IAM for user management, and all that stuff. So you pretty much have your Kubernetes service. You can create it with a click of a button. So you provision your EKS, you deploy your compute, and your compute, guys, is what we mean by those instances. When they say compute, they mean those instances that you create. And just like ECS, you have instances, but the difference between the instances in ECS and the instances in EKS is instances in ECS, they have container D, while these ones, they have kubelet. And kubelet is what enables the control plane to be able to communicate with your instances pretty much. So just keep that in mind, you deploy your provision cluster, it deploys your compute, and now you connect to EKS and you're able to deploy using the API. And then I just want to talk about YAML real quick. It's going to look a little bit complicated, but trust me, it's English. So if you see YAML, YAML just means YAML in a markup language. Normally, I used to confuse this with yet another markup language, but YAML is not. YAML is an English language pretty much in code. As you can see here, it says it's human friendly. And I'll show you what that means. The reason why I'm talking about YAML, like I told you, everything I'm talking about is what I do as a DevOps engineer. You're going to come across YAML a lot. Even when we're working with the CI/CD pipeline, with code deploy and code build, you're going to use YAML. When we start doing, I know Ansible is one of our classes right there for configuration management. Ansible uses YAML. Your CI/CD uses YAML. If you create GitHub Actions, it uses YAML. GitLab that I used to deploy, it uses YAML. So YAML is a lot common. CloudFormation, which I'm going to show you in a bit, it uses JSON and YAML, but you don't want to have to deal with JSON. That's why YAML is so advantageous. And that's why I'm just going to talk about YAML a little bit. I wish someone taught me YAML when I was learning DevOps, buying courses left and right. No one ever told me that you have to keep an eye on YAML, or you need to do a little bit of practice on YAML. But I'm letting you guys know, I'm giving you information. I use YAML all the time. And another important thing, when we start learning Kubernetes, all the Kubernetes manifest files, they're all written in YAML. Can you imagine? So YAML is like the heart. It's pretty much the heart. It's more important than Python as a DevOps engineer. If you understand YAML, it's more important than Python. So I want you to keep in mind. So that's why I just decided that it'd be nice for me to talk a little bit about YAML. Right down, you see EKS right here, you see?
Ashton, let that go. Sit down in that chair.
Guys, let's make sure we're all muted. It's always good to be muted, you don't want to be embarrassed in the meeting at work, I've seen it happen so many times. I've even seen a guy lost his job because, he didn't know his video was on. and he was basically, masturbating.
Oh no, chill, you're lying.
Whoa, Google that shit, bro. And that guy was like almost like a CTO, bro. Google it. In New York, yeah, he was watching porn. Why attending a meeting? Yeah. He got fired immediately.
I saw that on the internet. That's true.
Yeah, it's true, man. People do crazy things. And those are the ones that we know about. There's so many things that happen that the company will fire that person, but you won't see it in the public. You know what I mean?
Right.
But that guy was a popular guy. That's why you have to see it in public. But yeah, you have to be careful. So many times my wife has popped in and said something, but usually because I'm on mute, nobody heard it, but you could have put me in trouble. So if you don't need to be on talking, then my best advice to you at work or anywhere is to mute. And it's just a good practice, you're gonna see the benefits. Anyways, this is EKS. It's also easy when we study Kubernetes. So all these things, I don't want to take this a little bit and just know that this is not the end of it, because this basically, as a DevOps engineer, you're going to basically be working with this. So I'm just showing you now, just so you have in the back of your head. Create a cluster is as easy as putting a cluster name, but like I always say, everything you do here, you can do it in code. So you see now I have to create a role for your EKS cluster. I did create, and that's how easy you create a cluster. And when you create a cluster, you see you're going to specify the networking, you're going to specify the logging, and then you're going to create it. And then it's going to automatically create it with the node groups, and then you can deploy on it. So when we study Kubernetes, Kubernetes is such a broad topic. I don't want to go ahead and create a cluster if you don't know the internals of Kubernetes. It's going to be a disservice, because Kubernetes is a lot about Kubernetes that you need to understand. Once I teach you that, then we come and we create a cluster, and you'll be able to know exactly what we're dealing with and what we're working with. So we're looking at Kubernetes right now. We think it's just a cluster, but there's so many things going on. Netflix, Walmart, they all use Kubernetes. Even Love Every, the company, the website I just showed you, we're all using Kubernetes. So it's a big topic and it's very important. So don't worry about it. So I just wanted to talk about it just so you have it in the back of your mind. When we start studying Kubernetes, you get a little bit more information. But keep in mind that that's where most of your work is going to be. I build those all the time, clusters. Anyway, we're talking about YAML. And like I said, we'll be a service if I don't talk about YAML. So I'm just going to go ahead. It might look complicated. It's okay. But if just because I'm showing you this, when you start doing the DevOps practice and when you become your DevOps job, you'll not be as surprised anymore. When I became a DevOps, I didn't even know how important YAML was. And I saw it for the first time and I was confused. But if you see this right here, this is a YAML sample. It's so easy. It's basically English. You see these 3 lines you see right here? This is how you can separate 2 different files, 2 different. So if I put 2 lines, 3 lines, and I put 3 lines at the bottom, it means that anything that comes after that 3rd line is a completely different application. When you start writing Kubernetes, you'll see that I can use this and I can write different Kubernetes resource manifest files all in one page. But because I have these 3 dots here, you automatically separate them, isolate them. So I don't have to write 3 different pages, right? Okay, so as you see, it's simply a key value pair. So you have a name and then you have the value. This here is a string. You have array and you have a value. You have pi and you have, this is a floating point. So you see, you can easily put floating point variables like pi, 3.14, you can put pi. So this is basically English, guys. This is one of the easiest configuration of language, programming languages you ever see, because it's basically English. And the way you differentiate things is by indenting them. And then if you see 2 dashes here, you know it's a list. I'm just giving you the most important concepts. Once you understand this, you see that YAML is so easy. And whenever you see YAML, you're not going to be as intimidated. When you see 2 dashes, remember when you're watching, when you see 2 dashes, you know it's a list in YAML. When you see an indentation like this, you know it's a hierarchy. When I say hierarchy, what I mean is if you wanted to access this file, it means you have to access this file and then access this file to get this file. If you wanted to access this number 3, it means you have to go through this guy before you give you 3. So it's a hierarchy. If you wanted to access this number, I have to supply this guy. The coding language should take this guy as his first step, and then this guy will be the second, this will be the 3rd, and then you can access that language. So that's just how YAML is set up. It's just a bunch of hierarchy. If you want to put subsets, you just indent. That's how you do subsets. So this is yet another valuable information I'm sharing with you. If you do watch the videos and you practice and you understand all of this, you have no problems understanding DevOps concepts and actually taking interviews. So this is a basic YAML. This is JSON. You see how complicated JSON is? You need all this complicated, and you need to make sure everything is in quotes. But YAML essentially replaces JSON. This same file you see here, I think I have it in JSON. Oh, this file you see, this is the same file in JSON. Do you notice? JSON is so much more complicated. And these are the two languages that we use to store configuration files. We use JSON and we use YAML. As for me, I only use YAML because it's easy and straightforward. It's easy to read and understand. But when you start doing CloudFormation, this is exactly this. This is a YAML format and this is a JSON format. I hate JSON. JSON is so complicated. You don't have to worry about it because YAML is the #1 guy.
Hey, Linus, that was a question I actually had for you.
Yeah.
So we don't need to learn JSON, just read up on YAML?
Yeah, trust me, you're going to see a lot of JSON, but the good thing is you're not going to have to build it, right? The only JSONs you're going to see is JSONs that are provided to you by API calls, provided to you by other applications that other applications use, but you're never going to have to write JSON. You don't have to. If you look at those IAM rules that we have, before to create a role or user, or to provide, custom roles to that user, or to provide, custom, permissions to that user, you have to provide a JSON like this. But now you can easily just search the role you're looking for and it automatically spits out the JSON for you.
Okay.
Well, I think it will make more sense if I show you exactly what I mean. So don't get intimidated by JSON. You're going to see a lot, but trust me, I've never really had to write any JSON ever. Most of the time, like these policies, let me show you. If I wanted the policy for EC2, I just come here and I search that policy, and then once I search that policy and I open it, automatically you're just going to see, it spits out that JSON for you. And you can just copy it and go and paste it if you need it, you see? So everything has been done for you. You don't have to worry about that complicated JSON. But YAML, trust me, you want to understand YAML because you're not, I can tell you this, you can do so many things in DevOps engineering, but you're not going to get away without using YAML. Like I told you, Ansible uses YAML. Kubernetes uses YAML. AWS code CI/CD pipeline uses YAML. CloudFormation uses YAML. I can keep going on. And the advantage is YAML is easy. I mean, it's English. This is English. You write the name, the value, name, value, name, value, name, value, name, value, hierarchy, list, 2 dashes. This is English. It's not complicated. Most of your configuration files are going to look like this. And you see that in a minute. This is another yet sample. So you see the sequence. This is a scalars. The dashes, the list. Mapping, your name, value, name, value, name, value. Mapping scalars to value. See, this is America. You put name to this. So you're saying that in America, I have 3 teams. In national, I have 3 teams: New York, Met, Chicago, and Atlanta. And then you see the 2 dashes. You're saying that what you're seeing right here, what you're saying is I'm supplying a mappings of list mapping. So that's all you need to know about YAML, to be honest. That's how easy it is. That's all you need to know to be able to write YAML. And you just understand the indentations. That's all you need to know. You don't need any complicated if and else statements. Those who come with other templating formats, but this is all you need to know to understand, to start understanding what YAML looks like. So I just thought I'd bring that up. So when you're going through the slides, watching the video, you can just Google and chat, learn a little bit about YAML. Like I said, it's very important. Most classes won't teach you. When I learned DevOps, I took all kinds of classes. And no one ever even tried to teach me a little bit of the structure of YAML. Just even these 2 dashes a list. I had to figure out that on the fly, on the job. So, and with that being said, we'll look a little bit about CloudFormation. Does anybody remember what CloudFormation is? So, but does anyone remember what Terraform is? So Terraform is infrastructure as a code. CloudFormation is infrastructure as a code. But most companies, 90% of companies, they don't use CloudFormation, they use Terraform. But if you work in AWS, most AWS resources, they're going to use Terraform. When you spin up, for example, most of the things you do on the UI, sometimes AWS will spin up a CloudFormation in the background, but you won't see it, right? So it's important that you know about CloudFormation and know that they exist. I should probably open this up in the slide in its own. So that's what CloudFormation is. So it basically just models resources. So if you don't understand what I mean, I'm going to show you what a CloudFormation template in a minute. It looks complicated. You don't have to master it, but you just want to keep it in the back of your mind. If you have time, you can just practice because it's going to help you to understand what configuration infrastructure as a code looks like. You handle dependency. You can quickly bring up and bring down an infrastructure, and it controls and tracks changes in your infrastructure. So I know that doesn't make sense, but this is what a sample CloudFormation template looks like. And I'm going to go in there and play with CloudFormation a little bit so you see the magic in CloudFormation. But as you see, the template format version this year is always going to be the same, this date. You see a description, just a basic description, so you can put anything in here. And then you see resources. Do you see this? My EC2 instance. This is YAML. This is plain English. This is the same YAML format that we just mentioned. And you notice that CloudFormation is in YAML. You see, this is a subset, a hierarchy, resources under resources. You see, once you see an indentation, you know that what you're dealing with is a subset of whatever is an indented under. So if you have indentation under description, you know that is coming under description. So what I'm saying is, under resources, if I wanted to add a database server here, I would indent here and add a database service as the next indentation line. What's telling me is I want CloudFormation to manage my EC2, and I also want CloudFormation to manage my database. But this is a sample of EC2. With this CloudFormation template, I could be able to spin up a T2 micro, the key name, device name. So basically, you see the AMI. So basically, what you see here is what I did on the first day of AWS when I went click to create an EC2. Remember? This simple template you see here will do exactly the same thing. That's why CloudFormation is so important, and that's why CloudFormation is so cool. So remember, this same template you see here, okay, if I go back and say I want to create an EC2 instance, let me go to EC2. I want to create an EC2 instance. I'll come here, you know, where's EC2? I'll click something else. Let's see, EC2. Where's EC2? I know it keeps taking me to security groups. Anyways, I'll just click here. Anyway, so these are the instances that we have running. Some of them we have running. So I'm just going to make sure I only see the instances that are running. So just clean things up a little bit. So these are the two instances in my ECS cluster. Guys, you know, I go back and forth quite a while, but I know Alpha asked me about what are those EC2 instances, right? Remember when I created ECS, I created two instances. These are them. Do you notice that they're just EC2 instances? This is what is running the ECS cluster, the container service, but it's underneath is still an EC2 instance running. If you look at monitoring, you see that this is when the application was deployed. It used a little bit of CPU and then it's down. But this is just basically, but anyways, if I wanted to create an EC2 instance, let's say I launch an instance, AMI, I choose my AMI. We did this in the first slide, T2 micro, I choose my T2 micro. Next, configuration, I choose VPC and all this stuff. You see all this stuff we're doing right now? This is basically right here. You see, type EC2, property, image, AMI. We just looked at the AMI right here. You see, this was the AMI that we studied. You see AMI, this is it. This is my AMI T2. Key name, this is what we're going to do at the end. Block device mapping. And then you can even add more information like VPC and all that. But this is going to be deployed in 94 VPCs because there's no information with VPC. So I hope you get the idea. You get the idea now? So you're basically taking everything that you've been doing manually, and now you just put it in one code and you just run it. You can add security group. If I wanted to add security group, I'll just come and say, okay, security group, I'll set security group CloudFormation on my Google because I want a security group. That's how easy it is. I want my security group. I want to add security group to my template. So I'll search, what is my CloudFormation template for security group, right? That's what I'm looking for. CloudFormation security group. If I wanted to add a security group to my instance, I'll come here and I'll just search and I'll see, oh, this is it. This is a JSON and this is a YAML. I'll just copy this, right? I'll copy this and I'll just come here and I'll just add it. I'll just add it underneath here and then I'll fill whatever information I need to fill. You get it? You get the information now? So now this instance is going to have a security group. If I want my VPC, I'll just come search for VPC. Let's see if I can find VPC. I can search my VPC and then I'll copy that CloudFormation template and I'll just come and add here. And that's how you just keep building your template and building your template. And all of a sudden, you're going to have your VPC, you're going to have your EC2, you're going to have your security group. In fact, you're going to have your entire infrastructure ready in code. Trust me, and you can do this for your ECS, you can do this for AKS, you can do it for your IAM roles. You can create users and things like that using CloudFormation too. So CloudFormation for, I have some examples here, so I'll show you in a minute. So if you're getting confused, it's okay. So this is it. If I wanted to create a user, right? I'll copy this and I'll say, okay, IAM role, properties, the document. I'll copy the JSON policy that spits out each time you try to create a role. Description, I'll put a description. Policy here, and some of these, remember, some of them are optional, so you don't have to put every single detail. Permission boundary, if you have a permission boundary essentially you can put control and say, okay, this guy can do this, but he cannot do this. Role name, you put the name of your role, you tag it, that's it. It automatically creates a role for you guys. That's how easy it is. You create the same role that you go on there and click on it. But that being said, this is some cool stuff, but I know it's hard to understand. I totally understand if you don't get it. This is what you paste. So I'll go to CloudFormation now. Let's try to do a quick sample real quick. While I'm opening CloudFormation, I'm going to open some of my templates here. Let's see. Where's VS Code? That's not what I'm trying to do. I like to use the IDE because using the terminal can be painful. Oh, good thing everything. You see why another advantage of using the IDE is everything was saved. Even though I lost connection, I still have my files open. So what I'm looking for is this guy. If you see, I have a few CloudFormation templates. So this one is EC2. So I'll go through it real quick for CloudFormation template. So you see, forget about all these guys, all these complications. I'll tell you exactly what that means. But remember, as a DevOps engineer, once you understand the concept of CloudFormation, that's all you need. You're going to see CloudFormation here and there, but you don't have to reinvent the wheels. I promise you, anything you want to do right now, there's already someone out there that already did it for you. You can just search it, get whatever they use, copy that CloudFormation template, and just use the same thing and just change the values. That's how it works. So don't get intimidated. You see this? I didn't write this. I just copied it from somewhere, and then I'm using it. So don't try to reinvent the wheels. Everything has already been done. Whatever you're looking for, I promise you, 80% of what you're looking for, someone has already done it. So don't get scared. That being said, your CloudFormation template, is always going to start with this. Once it starts, it looks like this is in JSON. I would have loved for it to be in YAML, but the concept is the same. You have your CloudFormation, you have your description, you have your parameters, and your parameters is basically what you want your users to provide on the command line. So see, for example, I didn't want to provide my key name. Remember, where's that slide? So CloudFormation is a whole learning curve in itself, guys. So you don't have to understand it, but what I'm saying is I just want you to understand the concepts of infrastructure as a code. When they say infrastructure as a code, this is what they mean. They mean that you put everything in a code like this and it automatically brings up what you're looking for. You see here, we have our key name and you provide your key name, right? The difference between this key name, providing your key name on the code, and this right here is, this guy is saying that I don't want to provide the key name in the code. I want the user to be able to provide this as an input on the command line. You get the difference? That's what parameter stands for. So anyway, I'm just going to show you, I just want to show you how CloudFormation works. Like I said, I don't use CloudFormation a lot. I try not to, just because I think Terraform is better, but it helps you understand the concept of what you can do with CloudFormation. So you see resources, you see your EC2 instance, right? You have your instance type, security group, and all that. And then you come here and you see that's this security group that you created here, you're referencing right here. You see that? The ref is referencing this security group that you created here. So I'm saying that this guy needs to use this guy's security group. And then these are the outputs that I want when I launch. So I'm going to launch the same CloudFormation template and you see exactly what it creates. It's going to create me an EC2, so I won't have to create an EC2. I won't have to click. And it's going to create me a security group. This one just creates you an elastic IP. So usually you just go to the resources. It creates an EC2 instance. It creates the security group. It creates an elastic IP. It associates the elastic IP, and then you have a bunch of outputs. If I go to, do I have another one? VPC. We talked about VPC, right? You see, it creates a VPC. It creates a subnet. It creates an internet gateway. It attaches that gateway, creates a route table, uses a route in this route table that can connect that route table to the subnets using the subnet association and all that. Like I said, you don't have to understand all this stuff. I just want to show you infrastructure as a code to let you know that whatever thing you're building on the command line, you see this one is pretty intense. It even creates an instance security group, it even creates a web server on top of it, and even bootstraps that web server using user data. Remember we studied user data? You see this? It bootstraps that server. So don't worry about this. This is all, you just have to understand the concept that everything you're doing on the command line, you can do it with a script, and that's one of them. But you don't have to worry because we're going to do Terraform, which I think Terraform is better, and most companies use Terraform, but it's the same idea. It's the same idea. So let's go to CloudFormation. Let me show you exactly how that works. So I come here and I'm going to create a new stack, right? I'm going to create a stack. We call them stack. I'm going to create a stack here. And it's going to ask you, is the template ready? I'll say yes. It's going to ask me where that template is located, right? And the first time on the class, you can use a sample template, right? You can use a template. You see, they have samples here. You can create a LAMP stack. This is how you want to practice. If I wanted to create a WordPress block, this is a sample here. If in case you wanted to go back and practice. And let me show you something. If you put this, you can view the code in the designer. So everything is out there for you. I can go online now and find exactly what I need to find online and just come and paste it here and launch it. So as you can see, this if you go to the resources, you see that it launches a load balancer, the listener that listens on the load balancer, the target group. If you've been paying attention, you know exactly what the load balancer is, and you know exactly what the target group is. If you've been watching the videos, it creates a security group, another security group, and then it creates a launch auto-scaling launch configuration. Remember, we created launch templates, right? The launch templates houses your AMI ID and everything you need to launch an instance, right? That's the launch templates, what we've been doing in auto-scaling. It creates a launch configuration for you, and then it's going to automatically consume that launch configuration. And all these other things, you don't really have to worry about it. These are all, value output, but I just want you to get the idea that this is everything you're doing on the command line. Always remember that I can do this in code. Yeah, keep that in mind. That being said, I'm going to create an application. So it's going to ask me, do I have it? Where do I have it? I can say template is ready. Where do I have it? I have my template in S3. Okay, so it's going to ask you the URL of that S3. So I'm going to go to my S3. By now, I'm hoping that everyone is familiar with S3. That was the first thing we did in class. And the reason why we did S3 the first, because, I know how important it is. And look now, we're using S3. So what I'm going to do is I'm going to create a bucket, CloudFormation. By now, I'm assuming that everyone knows how to create a bucket. That was the first day of class. I'm going to enable versioning. I'm going to create that bucket. CloudFormation Linux. Once I create that bucket, I'm going to say, okay, now I want to upload. Now I can come to my bucket and upload those CloudFormation templates. But we don't have to do it because I already did it earlier. This is the same code that I just showed you. I already uploaded it. So if I wanted to build my VPC, the VPC code I just showed you, I'll come here and I'll look for just the endpoint for that. So where is it? This is it, the object URL. If you follow this URL, it's because normally if you follow that URL, it's because it's not public, but if you follow that URL, it's supposed to show you what your code is doing. But I already showed you what the code is. The code we're doing is this one. This VPC here. This is what I'm running. What I'm expecting at the end of the day is for you to create me. What I'm expecting at the end of the day is I want you to create me a VPC. I want you to create me a subnet. I want you to create all the networking and all that stuff for me, so I don't have to do it and all this stuff. So this is what I'm expecting it to do. Bouncing and back and forth between these things can be annoying. So yeah, so there we go. So I have I took the URL here, and I'm going to supply that to my CloudFormation template. So I'll just put that here. And automatically it picks it up. And remember when I told you before that there's a part for parameters, so just pay attention. It's going to sound really weird right now, but you're going to get the idea. Remember when I told you that if you don't want to supply it, you can put a parameter and then supply it on the command line. You remember that? When I said you could supply a key pair on the command line, like a key name, that's what the parameter will do for you. The parameter makes sure that you can supply it on the command line. So you won't have to just supply in the code. So this key name you see here is exactly what you see here. This key name is asking me for that key name because I said, okay, you know what? I want my user to be able to supply that on the command line. I don't want to supply that in the code. SSH is open. So stack name, I'm going to put my stack name VPC stack. Next, and I can put my key, I can put my tag, whatever I need to do with it. I can say if it fails, I want you to roll back. So this is a good option because you're saying that if it fails, I want you to take my infrastructure back to what it was before it failed. So this comes in handy if you want to start making changes to your code and start adding other things. For example, you want to add an ECS, you want to add an EKS on your cluster. You want to put this rule so that if you add an EKS and you launch it and it fails, it automatically rolls back and you have the infrastructure that you had before. So that's important. And then your rollback configuration. So yeah, guys, I just wanted to see that you can put everything that you do manually in the code. Like I said, I'm adding this. These are all extra stuff that I'm adding just so you can have that idea what infrastructure as a code is. It's just bonus stuff I'm adding you. But keep in mind that it's always important. If I'm adding bonus stuff, it's because I think that's important for you to know. And then that's it. I just create stack. And if you open the stack right here, you see that it's going to start creating everything that's listed in there. So my stack information is creating the resources. It's going to create, you see, it's going to create an internet gateway. It's going to create a VPC for me. And I'll show you all those when it's done. I'll show you. You see the things that are supplied on the command line, the key name and all that. You see here, the template, it gives you a template, it shows you the template that I just launched. This is even harder because it's in JSON. But if I look it in Designer, I can easily convert that JSON into YAML. So it's easy to read. So this is it. You see the same thing? That's why I love YAML. See, this is the same thing in YAML. It's much easier to read. YAML is much easier than JSON. You can clearly see that in the resources, I have my VPC, I have my subnet, I have my internet gateway and all that. These are the resources. Pretty straightforward. The resources, VPC tab, properties. See there. When you start using YAML a lot, you quickly understand what YAML does. So I understand if you don't get it, but these are all good to know. Remember, you're going to do your most learning on the job. But because you already have an idea of all this, it make your life easier, much easier. Any question?
Yeah, but YAML is kind of really confusing.
Yeah, it looks confusing, but after a while, you're going to see that YAML is plain English. After a while, obviously, I've been doing this for a little bit longer, but I'll tell you that YAML is one of the most easiest language that you're going to find. This is, for example, this is a simple YAML. You know, for me, you know, YAML looks like English because you just have whatever your version. This is my version. Just like you could come here and say name, Linus. That's basically what YAML is. You're giving them the name, the key, and you're giving the value, key value. You know, so yeah, it's going to look complicated, but after a while, you realize that YAML is super easy. This is a simple YAML that we're going to use to deploy our pipeline. Yeah, this is JSON, so don't worry about it. You don't worry about JSON. YAML is what we worry about. So I just wanted to show you what the CloudFormation is doing. So this is our VPC stack. And if you see it's creating our resources, you come to the events, you see what it's doing. It's creating orders, you see it's creating. And the good thing about this infrastructure as a code, guys, is if I wanted to delete my VPC, all of this, I just come here and I delete that stack. And it's going to automatically delete everything on here. And then if I wanted to relaunch the same exact thing, I just launch a stack and it will launch the exact same thing. Can you start to see how valuable that can be as an engineer? Then you can bring things down and bring them up as fast as you can, as fast as this, without writing any other code. The code is already there. You can keep reusing the code. That's one of the concepts that you have to understand. You just keep reusing the same thing. I promise you, if I wanted to create an Nginx application, I could say Nginx CloudFormation template. And maybe there's going to be, I promise you, there's going to be someone that has done it, see? There's going to be someone that has done it. And what do? You just copy it and use it. Guys, don't be scared. Everything is out there. Don't reinvent the wheel. Just know what it is and what it does. And then the rest will take care of itself. Because people have already done all the work. There's people out there that this is all they do. You know, you don't reinvent the wheel. You just understand what it does, and then you're always going to find what you need online. So don't get intimidated. So it looks like my VPC stack has created. You see, create complete, output, resources. You see all what it created? That gateway that we saw, IP address, remember the internet gateway, security group, ACL, VPC, subnet. He created all that for us just by writing code. If I go back to my VPC, let's see, if I go back to my VPC, I should see my new VPC created and all that stuff. I should have given a name to that VPC, but let's see which one was created recently. Yeah, I can't even tell which one it is. Let's go to that code and try to see if we can find more information. Okay, this is a VPC ID. It ends with 9B6. So let's come here. You see 9B6? He created our VPC for us. And then he created many other things. And this is, you can use this to do so many other things, guys. You see the potential. If you go to your internet gateway, if I wanted to bring everything down, it's as easy as going to my stack and say, delete stack. That's it. It's going to delete everything for me. If I wanted to create the exact same thing, I'll go back and use the same template that I just used, and it'll bring back the exact same thing up. Guys, it makes your life easier as an engineer. And you have to, this is going to be one of the best skills, to be able to put everything in code so you don't have to do it over and over again. If I wanted to create 10 VPCs, you know, I'll use the same template and create 10 different VPCs without having to do anything. Let's go ahead and while that's deleting, let's go ahead and create another stack. I'm going to use one of the other templates that I have. Let's see, there's more template. I have one more. I have the EC2 one. Let's create an EC2 template. Let's use this template to create an EC2. I'll copy the endpoint as usual. I'll come back to my CloudFormation and I'll create a new stack. So I'll just put that same link here and next. And besides, let me show you in Designer. Let me show you the code. I'll show you in YAML so you're not confused. YAML. So you see there's a description. Let me explain exactly what that does. So we create, you know exactly what we're expecting. There's a few parameters. I'm going to supply my key name. I'm going to choose between my instance type T2 micro. The default is too small. So if I don't provide anything, it's probably too small. But it's telling me that I can choose from any of these instance types. And then these are the mappings. And then what we're more concerned about is the resources. What I'm expecting it to do is going to create me EC2. It's going to create me a security group. And that's it. It creates my EC2 instance and the security group. So I don't have to go click to create. So this one is pretty straightforward. And then it's going to provide me a few outputs that I might need, like the public DNS. The reason why this is important is because you can create your application at EC2 and do a user data and bootstrap, let's say, a web application on it. And once it spits out this public DNS, you can go on that public DNS and be able to access the website. So that's the reason why you have outputs. But that being said, I need to go back. Looks validated. So let me go back to what we're doing. So we have our template there. In fact, let me post it again. So now I'm going to put my stack name. I'm going to say I want to create EC2 plus security group. Security group. You see those, the list that I showed you with all the instance type that I can choose from. This is exactly the same list you're seeing here. It's not rocket science, guys. It's exactly the same list I just showed you. Like I said, the CloudFormation looks difficult, but you have to understand, what I want you to understand is the idea and what you can do with AWS. You can put everything in code. You don't have to click every time. You can have a CloudFormation or Terraform do it for you. This is essentially what Terraform will do. So when we get to Terraform, and I talk a little bit about Terraform, you know exactly what we're expecting, right? We're expecting Terraform to be able to create infrastructure for us without us having to click. So rollback, so that's it, stack policy, all that. And next. When you go to an interview, you can boast and say, oh, I know CloudFormation and all that stuff. But I promise you, your companies rather prefer you to use Terraform. But I still use CloudFormation every now and then. The concept is still the same. It's just that Terraform is just a lot more flexible. Anyway, I deleted the previous stack. So what I'm expecting is this VPC should have been deleted, right? So let's refresh and see. Do you see? It automatically took care of everything for us. I don't have to come and I don't have to come here and say, oh, DevOps, and then come here and say delete. That would be too much work, right? Look, if I didn't have that, I have to do this, and then I have to go to the subnet and say, oh, delete. And then I have to go to the internet gateway. Where is it? And then click on the internet gateway and then delete. I have to do it for all those resources, but no, I can just use CloudFormation. So this EC2 is being created. So what I'm expecting is when I come here for the EC2s, as you see, like a new EC2 instance is being created. Guys, I know it's complicated. Feel free to ask me any question. But what I'm showing you here is valuable information, and valuable information is not a piece of cake. But at the same time, I can promise you, this thing is not hard. If you apply yourself to it, it's not hard at all. So don't get discouraged. So do you see right here? Do you see that it's creating an EC2 for me? This is the EC2 that is creating for me. Oh, it's already created. It's initialized now. So is this guy that's doing all the work for me? Like if I come here, you see it's creating one EC2 instance and it's creating an instance security group. And this is the idea of the security group. So we have our EC2. If I go to my security groups, can I find the security group? I'll just use a shortcut. In fact, so yeah, so these are the security groups. And if I search, I should be able to see this security group that was being created for me. EC2 sec group. I should just follow it for me just because I don't know what the security group ID is. But this is what it is. So I'm just going to copy this. It ends in 2ED. So if I open EC2 management, it ends in 2ED, A2ED. So if I come here, I'm looking at, this is it right here. So it automatically created that for me. Let's go back to our EC2. We see that our EC2 has just been created for us. Think about it, guys. Now we don't have to go and click launch instance. You don't have to go and choose. You don't have to do all this. And you can do this and you can use this thing to create multiple instances. So you see how easy it is? So if I wanted to delete this, I'll go come back. It's the same thing. It's the same thing. I come here, I click on the stack and I say delete. I delete stack. And oh, I forgot to show you the outputs. These are the outputs, the public DNS. All those outputs I told you, this is where you get it from. But anyways, let's go back and let's see how it's destroying that instance for us. You see, it's gone. You notice? So yeah, CloudFormation is cool. Any questions? I know this is a lot to take in, but any questions, guys?
Yeah.
Does it make sense though?
Yeah, I'm trying to digest it, but then let me ask a quick question.
Mm-hmm.
So what you're trying to insinuate is there are standard templates online to create various instances.
Various resources, not instances.
Resources.
Yes.
So if I have to go online and search, it's gonna give me like a standard template I can use to create my resource.
Yeah, it's going to be standard templates that other people have already created for you.
So I just copy it.
Just copy and use. It's all open source. Yeah, you might have to change. Maybe the name of the VPC might not be the same as yours, right? So you might just have to change all those little details. But yeah, you have the same templates. You don't have to write all of this from scratch, man. I'll never do that. Me, I'll copy everything online and just put them together. Or sometimes you find exactly what you need. You know, so don't worry about writing any of this. Even Terraform. Even though we're going to study Terraform, you're still going to see everything online. And if you don't want to do it online, you still have the official documentation here. Me personally, I'll go online and I'll search, and I also use the documentation here. As you can see, you see every resource on AWS, you can put it in CloudFormation. You see CloudWatch. This is a login that we're talking about. You can put it in CloudFormation. Code default, ECR. You can create an ECR repo using CloudFormation. You see? I can create an ECR repo with CloudFormation. So what I'm telling you is anything on AWS you can manage with CloudFormation. You see? So maybe this documentation is something I'm gonna put this in the chat. But yeah, anything in AWS you can put in CloudFormation. I don't have to do it by clicking. You see here? Everything on AWS, all the services in AWS you can put in CloudFormation. Just like all the services in AWS, you can also put in Terraform. So yeah, just keep that in mind. It's some hard stuff. DevOps is not easy, but once you learn it, it becomes so easy and they pay so well. There's so many jobs that the interviews are just, now what they do is they just give you a project. So if you're able to do your interview, your first round of your interview, and you're able to do your first round and you go to the second round and they give you a project. Oh, that's the easy part. You just come and we find some time and we knock out that project and that's it. You just go to an interview and talk about that project and you get a job. Even my company has a project. You know, I can show you, I'll show you all this project whenever I think you're ready and you see what the project is. And that's for a senior position. It's a trash project. And I was just looking at it, I was just laughing. You know, it's an easy project, you know, it's an easy project. So I think the project that my company has, when they're hiring for a senior position, I'm going to add that to the project that we're going to do at the end of the class. And I think it'd be really nice, including the ones I planned. So if you're all good with this, there's two options. We can end class now, or we can go ahead and I can build that CI/CD pipeline so you guys can see how it works. You guys let me know. It might take some time, so we can do it next class or we can do it right now. And I can build pipeline. Right?
I said we do that next class, man. I'm tapped.
You tapped, huh?
It's just so much information, bro. Like, it's a lot.
It is.
And I think putting it in practice, like when you do build a pipeline, because you're gonna use all these resources and everything to do that, right?
Yeah, but for CloudFormation, for the being the CI/CD, yeah, I'm just going to build the pipeline visually so you can see. But I'm going to use. Did I stop share?
Yeah.
Oops.
Or what will you be using?
I'll be using the YAML code that I just showed you.
Uh-huh.
And then I'm just going to build a pipeline step by step, and then we're going to put everything together.
Okay. I think that will.
I'll show something real quick. Hello?
Yes.
You know, we are students, so you know, you're already versed with this. So there are certain languages that you use and you go really, really fast. So if there's a way that when you use certain languages, you can break them with like.
Yeah, you can just let me know. What language?
Yeah.
What language?
Yeah, we know you're using the language. So if you can break them with like little examples.